We learned how to use the slopes, or the limit of the slope, so to find the slope, and usually slopes are straight lines, but we use the limit to find the slope at a point of tangency. So we know that the limit of the slopes is the slope of the tangent line to the curve at a particular point, at that point of tangency. So that's what we learned in D1. See, you learned it already, Rahat, and you're already on reels. Put it somewhere. Okay, so just to summarize, I'm going to use my highlighter here. This is our secant line. What's the difference between a secant line and a tangent line? How many? Has 2 points, right? So we need to use a secant line to find a slope because you need 2 points on a line. So our secant line is straight, and that's what we're measuring the slope off of. So the idea is as the 2 points get closer and closer and closer to that point of tangency, so as this point moves closer to this point, we're going to get a more accurate thing. That's why we're doing limits of it. This one is my tangent line, and the point of tangency is the single place where it hits the curve. So this right here at A, that's my point of tangency. So this is all just D1, like that's just a review of D1. But the whole goal here is to move the second secant point closer to the point of tangency. And the closer we get, the more accurate of an estimate we get. So when I'm talking about A and H, A being the point of tangency and H being some distance in between them. The idea is we want to get H really, really, really small. We want to get that increment between the point of tangency and the other secant point. We want that to be like really, really small. So what we want to do is in this derivative here is we're going to use this difference quotient. So it's like subtracting and dividing all in the same thing. So we go back to that formula again, that slope formula, and we take our farthest. So this is our secant point. Secant point, and that's like the second one. And A is our tangent point. And we're going to subtract them. So on the top, those would be our y values. F of A, that's just f of x, right? Like that's just our y value there. And then on the bottom, we have our x values. And that's just a slope formula. That is the y value of the second secant point. Because if f of A is our tangent point, the h is the little distance between them. So what's happening sorry, I'm a little high here. What's happening right here is a distance of h. And our goal is to get h really, really small, so it's really, really close to that point of tangency. And we've done this before in our table of values, right? We go by really, really tiny increments. So this is just what we did the other day. It's just the slope formula, but it's simplified. So on the bottom here, it's the x value of the secant point minus the x value of the point of tangency, and those will cancel each other out, leaving us with just h on the bottom. So that's just the math behind it, and it looks a little weird, but it's really not that bad. Okay, so now let's do this. So we're going to determine the slope of a tangent line to the function 3x squared minus 1 at x equals 2. So what do we know? Oh, sorry. I want to sneeze, but I can't sneeze. All right. Where's my point of tangency? X equals 2. So we know that this point is your point of tangency. Okay, so that's really important because really what does this value turn into? It turns into the A value in that previous like gray box that we did. So that's the point of tangency. So that's the X value of the point of tangency. Okay.
So Ms. Clark, to find the secant value, do you just plug that into the formula?
That would only find us our Y value of the point of tangency. Should we do that? Do you want to find that? We could do that. So let's find what's the Y coordinate of my point of tangency.
11.
11. So it would be 2 and 11. And if you're unsure how we did that, we just substituted 2 into this equation. 2 times 2 is 4, 4 times 3 is 12, 12 minus 1 is 11. So our point of tangency is at 2 and 11. That'll be helpful in a second. Okay. What do we want H to be? What did I just say we wanted H to be?
Very low.
Really, really, really small. Really, really, really small. So I know what X is. I'm not really worried about X. What I am worried about is H is approaching. So H is approaching 0. Because I want the distance between the secant point and the point of tangency to be tiny, 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 tiny. We'd like it to be 0 because we want to get to just that point of tangency. So we're looking for the distance between the 2 points. Let me flip this back over. We're looking for the distance between these 2 points to be so close, it's approaching 0, that there's no distance between the 2 points. There has to be distance between the 2 points or we can't calculate anything, but we want H to be approaching 0. And so now we're looking for the slope. So what's the slope formula? Okay, so we know that our point of tangency, I'm wondering what the best way to write this is. Okay, we know our A value is 2, because that's our point of tangency. So that's that. So the formula was F x plus h minus f of x. Oops, sorry, these were A's. I didn't use an erasable pen, so we're gonna have to just deal with that divided by h. All right, and so we want h to be approaching 0. We want it to be so small that it doesn't exist. So the trouble with this is if I just do direct substitution, what's going to happen? I'm going to have a divide by 0, right? It's going to be an undefined. I'm not even sure what the top would be. I think it'd be okay, but we've got to define by 0. So I got to do some more math. So what I'm going to do is I'm going to substitute some values in. And I might switch pens because I want to use an erasable one. All right. So it's saying in this function, and what did we say A was? A was 2. So we have f of 2 plus h minus f of 2 all over h. I don't know what's going on in... I don't know. Okay, so the limit as h approaches 0, we're going to substitute information in. We're trying to find f of 2 plus h. So we're going to fill that into this equation here. So anywhere we see the variable, we're going to replace it with 2 plus h. So we're going to have 3, 2 plus h squared minus 1. I'm going to put some brackets around that because that's that. And then we're going to have f. So we're going to put brackets around this. 3 times 2 squared minus 1. But you guys already know what that is because we did that little bit of math off to the side. Oh, so much math. So all I did was expand this. In my head, I just did 2h times 2 plus h. And I just did the math and I got this for an answer. I think that's right. Okay, so we gotta do some more math here. We're not done.
So we just murder the 12 out there.
What?
Murder the 12.
Why would we murder the 12?
Since 12 plus 12 minus 12.
Okay. And so I haven't done any direct substitution, so you see that I got to put that limit as h approaches 0 all the way down. So I'm going to have 12h plus h squared over h. Now again, if I went and did direct substitution here as well, those aren't n's, those are h's. I know they come. Yeah.
That's 3h squared.
Oh, it should be 3. Yeah, sorry. And this is why I used an erasable pen. Someone asked me the other day why math teachers get so upset when you do your math in pen, and it's like, but we always make mistakes, no matter how good we are. If we do direct substitution here, it's still not gonna work, so that means I have to do more math. And what I'm gonna do here is I'm gonna common factor that h out. Now, I'm showing you all my steps. I'm showing you all my steps just so that you have a full and complete understanding of what's going on. I can take out a 3h, and I'm left with 4 plus h on the inside. And now it's obvious what we're going to do. We're going to cancel out the h's. My denominator's gone now. And so if I do direct substitution in here, I know that this will have a value of 12. And maybe I'll just do that right here. 3 times 4 plus 0 is going to give me 12. So we know that the slope of the tangent line at x equals 2 is 12. It's a little bit of a mouthful, but we know that the slope of that line at the point of tangency is 12. So there was a whole bunch of math I had to do, but it's not, if you stop and think about it, it's not too terrible. It's a lot, but it's not too terrible. Okay, now we're going to talk about it. All right, so we call this value. So this value is the limit at x, so that's your point of tangency, is called the derivative of y in respects to x. It's a little bit of a mouthful. So the derivative of the f of x function is sometimes called f prime. We've seen that prime symbol before. Whose value at any point x on the domain is the slope of the tangent line at any point. So all it is really is the derivative is the slope of the line at a point of tangency. That's what your derivative is. So it's this is the most important part, it's the slope of the tangent line. So this is always going to be our slope formula from grade 10. So when we're doing derivatives, we're going to be putting in that slope formula over and over and over again. And x is going to be that point of tangency. So the x that gets represented here is your point of tangency. And it's always going to be h approaching 0. That's always going to be the h approaching 0 because we're trying to get that small distance between the secant point and the point of tangency. So this switches gears now. Before we were always x approaches something. Now because we're looking at slope, we're trying to get the secant point and the point of tangency closer and closer and closer and closer and closer together. So that's our goal. So this is something that you have to remember. And I believe this is on your formula sheet, question mark. I'm pretty sure it's there. All kinds of different notation for this. The first three are the most common. Like this one's the most common. This one stresses me out, that one stresses me out, and that one stresses me out. So I tend to stay here a lot. Those are three different ways of representing it, but you may see it written just so you know when you see it, it all just means the same thing. And we're also going to do different level derivatives. So what we're going to work on today is the function and its first level derivative. If you have a second level derivative, we'd have prime prime. And if we have a third level derivative, we'd have prime prime prime, right? So it will tell you your level of derivative that we're doing. But we're just going to start with the first level. Hello. Yeah, but I don't have the thing because I used it for Adrian. Is he there to pick it up? If you could come pick it up tomorrow, I just need to get the contract. That would be great. Okay, thank you. Bye-bye. Okay, okay. And we'll do more with those derivatives in D5 lesson. Okay, so we're going to find the derivative using the definition of derivative, which is this right here, which is just the slope formula. We're going to determine the derivative of x squared. Okay, so notice I didn't give you a point of tangency. So no point of tangency was given, so essentially we're doing it for all values. And so what's going to end up happening here is we're not going to get a number like the first question that we did. Here we got a nice 12, easy peasy, we have a specific point of tangency. This is almost like a general solution or creating an equation for your first level derivative. So if no point of tangency is given, you're going to get an expression. You're going to get an expression. You're not going to get a number. If a point of tangency is given, then you're going to get a number. So two different types of questions. If point of tangency is given, we're going to get an actual number for our answer. If no point of tangency was given, you're going to get an expression. Just because we don't know what x is yet. All right, so we know that we're looking for the limit of the slope. So we're looking at h, that distance between the 2 points getting smaller. We know that it's the slope formula, so it's going to be f of x plus h minus f of x all over h. That's the definition of a derivative. That was given on the other page. It was given on the first page. We're replacing it, the a with x, because we actually don't know what x is equal to. So here we go. We're going to fill in some things. So the top line of this, we are going to fill in anywhere you see the variable, we're replacing it with x plus h. So here's my equation right here. So I'm going to have x plus h squared minus, and this is just f of x, so this would be x squared all over h. Okay, we're going to expand that binomial. And if we expand it, we should get x squared plus 2xh plus h squared minus x squared, because that's just that one right there. And that is that. And we are going to combine any like terms that we have, which happen to be the x squareds on this one. Am I going too fast? Do you guys need a second to get caught up with the writing? Okay, so this is gonna leave me with 2xh plus h squared over h, because the x squareds will cancel each other out. Again, if I did direct substitution at this point, what would happen?
You still have an undefined?
You still have an undefined, so we're gonna common factor out that h. And now we can go ahead and remove the denominator. So if we do direct substitution at this point, what's my simplified expression? 2x. So we would say f prime x is equal to 2x. So this is the equation of the first level derivative. So if I said our point of tangency was at 3, what would be the slope? 6. So that's what this is helpful for, is that if I now give you a point of tangency at this point, and I say x is equal to 3, you know that the slope or the limit of the function is going to be 6, because you're just going to substitute it in to that expression for the slope. Okay, so now we're going to get a little bit more complicated, because that's just what we do and who we are. And you can see that these take up a lot of room. So your assignment is like 3 questions, but each question gets a full page to do it, because there is so much math that goes on the page. Okay, so we're doing the definition of derivative. We know we're just finding the expression because I have no point of tangency. Now, something that helped me was if I do x plus h, if I just do this off to the side and put that into the equation, that's going to be x plus h minus 3, and then f of x is just going to be the formula. I don't know if that's helpful or if you prefer to do it inside the equation, but sometimes just doing it off to the side, you can jump right into substituting. Because we know, so it's going to be h approaching 0, because we're always trying to get that distance between the secant point and the point of tangency closer and closer together. So we're always taking, I'm going to write it out just because I think it helps my brain. That's the formula, like that's the always formula. That's what it's going to be. Okay. So now I'm going to substitute this stuff in, and this is an ugly one. So this gets replaced with that. So it's going to be root x plus h minus 3. Now all of that's under the root sign. So what we consider that is a single term. Okay? We consider that a single term. And so then we're going to be subtracting root x minus 3 over h. So this is a binomial, well, I'm going to call it a binomial. It's got 2 terms, 2 radicals in it. So now I'm going to multiply by the conjugate.
What would be the conjugate?
Okay, what do you think the conjugate would be? Remember that the conjugate is the difference of square partner, missing factor.
Oh, so is that...
Tell me what you think it is. Rahat, you're leaving me hanging. So the thing that has to change, and I've noticed on your last test, that a lot of people are changing the signs under the root sign, and that's not correct. When you do a conjugate, it's the add or subtract that changes. So if this is subtract here, this has to be add, add. Okay? Okay, I'm gonna do this on a separate piece of paper, and some of you won't need to see this. Most of you probably won't need to see it, but I'm gonna show it to you anyway. I'm just gonna do those numerators really quick, because oh, sorry. Okay. This times by itself is just saying that you square it, right? So what happens when you have a root sign over it?
The roots cancel out.
The roots cancel each other out. So we're left with x plus h minus 3. And then that would be, I'm just going to leave them as radicals. Not even going to worry too much about it. How's it going, Mr. Odette?
Not too bad. How about yourself?
Delightful. Is there anything I can help you with?
So, almost as well as it is for me. You know what I just decided I should do for my next blackboard is a big Mondrian replica.
Ooh,
Because the black lines are already done.
already done for you.
When you get a chance, no rush.
Okay, I have to do it on my downstairs computer.
Yeah, that's why I figured I'd just.
Slide
make
me the
you
number.
carry around
Perfect.
that piece of paper.
Wonderful.
I can email that to you. if you
Nope,
want.
that's good. Paper's good.
And you got the.
I
you got
did. I
that?
saw it. That's beautiful.
It's fairly an old one, but I just stumbled across it in the box and I realized this, when I first got it, I did not
Didn't think of
realize
it.
it was a Mondrian, but.
There
now
it
I
is.
do. Now I do. Okay, thank you again.
No problem. So those two, again, you're multiplying it by yourself, but this time one's positive, one's negative. You're squaring it, but it's going to be minus x minus 3. So what we notice is that these two, it's a difference of squares, so those middle terms will always cancel each other out. But keep in mind that you are subtracting whatever was under that root sign, so that negative is going to end up getting distributed. I just don't have enough room to do all of it. So when I do my next line, this is going to be x plus h minus 3 minus x plus 3 all over. I'm going to leave that all in brackets if you're okay with that. X plus h minus 3. What are you doing, Rat? What are you doing? Okay, I feel you. All right, so now I'm going to combine like terms on the top. I'm going to combine like terms on the top. So h's end up canceling each out, 3's end up canceling out. What's left on top? Just a lone letter H. So you find with this stuff is that oftentimes I don't do a lot of multiplying through because they end up canceling in the end. So if it looks ugly to multiply, then don't multiply it because chances are you're going to end up canceling it out anyway. So these are going to cancel each other out, leaving me with, and this is an easy mistake to make, you have to have that 1 on top. Okay, so if we were to do direct substitution in here, we would have 1 over root x plus 0 minus 3 plus root x minus 3. I'm just going to bring that up here. I'm kind of running out of room. That's a subtract sign. It kind of looks like a multiply. So we know that the first level derivative formula is that. Now we're going to get to some basic rules and things are going to go a lot faster, but with these ones you have to do it the long way. Like there's no quick rule around this one. This one's ugly. So if I asked you to complete something using the definition of a derivative, you have to do this entire long way. We're going to learn some basic rules tomorrow, and those are going to go a lot faster. You're going to learn kind of like the exponent rules. Instead of having to like multiply everything all out, we're going to learn a faster, quicker way to do the rules. Okay, last one. Last one. So, am I going to get an expression or am I going to get a number? A number. How come? We have the a value. We know what x is. So we know because we have the point of tangency, our answer is going to be a number. So right away I know that. Okay, so what I would like you to do, you ready for the what I would like you to do? I'd like you to do the definition of derivative. So we're going to do it without this point first. And I want you to create me the expression of the derivative. And then we'll substitute it in at the end, just like we did before, but I want to work this one through. So I'm going to set it up, and you guys are going to go. So I'm going to start doing this. I'm going to say that g of x plus h is going to be x plus h plus 1 over x plus h. And then g of x is obviously just the equation. So all I did was right off the bat look at my two g of x plus h and g of x and just created those two things so I could dump them right into the limit formula. Now this one, usually it's f of x, but my function's name is g of x this time. So I gotta adjust it. So it's gonna be g x plus h minus g of x all over h. That is the derivative definition. That's, anytime you see the definition of the derivative, that's what I'm looking for you to do. Okay. What strategy are you guys going to use here? Common denominator. So, Anirudh, what is the common denominator? And you're just doing common denominators on the numerator, right? So what's the common denominator here?
X times x plus h.
X times x plus, yeah, I'm with you now.
X squared plus
So the strategy, I don't think I would do that. And the only reason why is because I want to look at what I need to multiply by. So my common denominator just for the numerator is going to be x times x plus h. Lots of people just try to multiply by h, but you can't multiply something and have it turn into an addition symbol. So if I look at my first one, this one's missing x over x. Now remember that numerator is the whole thing, right? So, and then this one's missing x plus h. And I will tell you to multiply those numerators. Okay, go ahead, do your math. I'm not going to be any more helpful. I'm gonna freeze my screen and keep going, and you're gonna keep going. And this is just algebra, but it can get kind of cumbersome because it doesn't look very nice. Can I show you what I got? Maybe. So I left you at the pink line, and I went ahead and multiplied it through, and then I canceled a bunch of stuff out. And I was left with negative h over my common denominator. And then it was over h, but it was getting too many lines, so I just wrote divided by h, which helped me later on do that. So I know that my derivative,
How do you get it divided by each?
well, because it was all over h,
Oh,
right? So I just didn't want to keep putting like line and line. It gets very confusing, so I did the divide, like I just moved that to there. It means all the same thing, but I find it looks a little easier. So we know that g prime of x is equal to 1 over x squared. And it shouldn't be f prime because the whole equation was about g of x. So that's like the introducing a new variable without defining it. So make sure you're using g of x. And so now we have our point of tangency. So all we have to do is substitute it into the derivative. So the slope at -2 is -1/4. Okay, so I'm going to tell you that all of these questions, I want you to do the definition of the derivative first, so you're getting the actual derivative, and then you're substituting in the point of tangency. So you have 3 questions to do, and I want them all to be like this last example, where you create the derivative first, and then substitute it in for the point of tangency.